Okay, let's take a look at problem number 30. We have the limit as x approaches 2 of the following. Okay, so this is going to be the absolute value of x minus 2 over x minus 2. Now what I'm going to do is I'm going to write this. This up here is can be defined by a piecewise function. So let's talk, before we do any work over here, I'm going to talk about the following. Let's look at f of x equal to the absolute value of x plus 2. So that's two different, we can define that as two different functions over different intervals here. Okay, so our interval spot, x minus 2. Our interval spot will be, our division will be at 2. Okay, so watch how I'm going to do this. Our original f of x, if f of x was the absolute value of x, we defined it as follows. As x when x is greater than or equal to 0, and then as negative x when x is negative, right? And when x is less than 0. So we've already discussed this. Well, let's apply it to here. So it'll be x minus 2, okay, when x is greater than or equal to 2. Think about how I got these values. If I were to plug in for this guy, so here, if these were the same, then this would have been x minus 2, and this would have been x minus 2 is greater than or equal to 0. And if you solve for x, you end up right back here. Okay, so let's erase this. And now if we do the same thing, if we plug in this, we have negative x minus 2, and that's when x is strictly less than 2. Now let me erase this down here as well, and we can rewrite this as x minus 2 when x is, and actually, you know what, I'm not going to rewrite it, I'm just going to leave it the way it is. We'll be able to play around with that. So that means that this guy right here, okay, so let's just call this guy over here, I don't know, g of x. If g of x is the absolute value of x minus 2 over x minus 2, then as a piecewise defined function, I would get the following. I would get, it's going to be equal to x minus 2 over x minus 2 when x is greater than or equal to 2, and it's going to be equal to negative x minus 2 over x minus 2 when x is less than 2. Okay, do you see how I went from what's up top here to down here? Okay, which means if I just do a little bit of simplifying, g of x could be defined as 1 when x is greater than or equal to 2. Actually, I shouldn't say that. It's not 1 when x is greater than or equal to 2. It's 1 when x is strictly greater than 2. Think about why we can't use 2 in this situation. In fact, we need to redefine this as well, because 2 is not even in the domain here. Okay, and then if you take a look at this, these guys would cancel, and this would just be equal to negative 1. That's a really bad 1. Let's go ahead and fix that. When x is less than 2. So what does the graph of this guy look like? Well, the graph, let's see if I can draw that a little bit better. Let me go grab a straight edge. Okay, so let's graph this guy out. So the function takes on values of 1 Okay, so at 2, when we're greater than 2, it takes on values of a height of 1. So not there, but this way. Okay, so what I'm doing is I'm looking at this to graph my piecewise defined function. And then down here, when x is less than 2, it's at negative 1. So from here, this way. Okay. Now we have a situation where we have a limit, right? We've got to come in from both sides. As I come in from the right side, so here's what I'm going to write down. The limit as x approaches 2 from the right side, that's the green part here, of the absolute value of x minus 2 over x minus 2, that is equal to the limits as x approaches 2 from the right of. Now, for anything to the right of 2 over here, we have a height value of 1. And of course, we know the limit of a constant is just that constant value. So this would be equal to 1. Now that's coming from the right side. The limits as x approaches 2 from the left side of the absolute value of x minus 2 over x minus 2, that's equal to the limits as x approaches 2 from the left. And we know that all of those values, as I come in here, all those values are at a height of negative 1. And again, the limit of a constant is equal to that constant, right, of a constant function. Now here's the point being is that the limits as x approaches 2 from the left of x minus 2 over this is not equal to the limit as x approaches 2 from the right. And that implies, that's what this arrow means, that implies that the limits as x approaches 2, oops, that's supposed to be minus down here, does not exist. There is no limit because our limit from our left hand side is different from the limit coming from the right hand side. So since we have different limiting values from those two sides, the overall limit doesn't exist. This is your argument, okay? Now if you want to, could you just put down this stuff right here? Yes. So let me just box this out here for you. This is what I would expect to see on an exam for a solution. This stuff up here is your work to visually justify to yourself why, well, one, what's happening with the function, and then what it looks like. You can do the same approach here on a graphing utility, a graphing calculator. Okay.